Hey there, we're going to work on the walkthrough for the tryhackme room ice. So let's go ahead and start up our Kali VM as usual. All right, and our login is Kali. All right, we're in. And as usual, I always like to log in and check ping Google. You can see it in my history. Man, can I show y'all something real quick? I don't like this prompt. So this is taking time to do something that's not strictly required. I'm sorry. I'm going to install a particular thing, and I'm going to cheat and use this script that I wrote to do all of this. Oh my ZSH. So this, paste. I'm also going to get a decent nano config. Copy. And then I'm going to install power level 10K. It's just something I've gotten really used to using. So and then might as well do my tmux thing as well. I probably should just run the whole thing. How about that? But okay. So Control D, I'm gonna open a new terminal, and it should prompt me to do like this new configuration thing. And this is power level 10K. It's a cool, just different prompt like than the one you were messing with before. So let's see, does it look like a diamond? Yeah, it looks like a diamond. Does it look like a lock? Yeah, it looks like a lock. Does that look like the Debian logo? No, it does not. No, that does not look like Python. Those are clues. Icons overlap neighboring crosses. They overlap. So this is entirely up to you, whatever you like. I'm going to go with rainbow because it looks fun. And then I'm going to choose Unicode. I do like it to show the current time in 24-hour format. I like it to show the angled brackets or like the separators. I like that to be pointy and the tail to be flat as well, not faded or blurred like the other ones. I like it to be on 2 lines. I don't want it to be connected. I do not want a frame. And what that means is just like wrapping the top and bottom. I like it to be spaced out. I don't want to see a lot of icons. I do like it to be fluent because it'll tell me how long the last command took to run or how long the last command was running. And then I do not want a transient prompt. Let's see. This one is asking me like instant prompt. I just go with the default thing here. I haven't noticed anything wrong with doing that. This is asking me if I want to save the changes I've made. So yes. And you can see that my prompt now looks different. And every time I open a prompt from now on, it should look like that. I'll see the time over there in the top right, ls. As I cd into directories, it sort of fills out again. I've just gotten used to this look, and I like it. Yours should work just the same in either case. If you wanted to use bash, you're going to get the same effect, right? So this was ZSH, and now I'm in a bash shell. I can ls cd downloads. It looks more or less the same. I just prefer the Z shell. So at any rate, you can see I was in there for all of 23 seconds. It was interrupted. And now the current time is, according to the Kali VM, 11:41 and 43 seconds. So you can clear to clear the screen. All right, so now that we've wasted a couple of minutes doing that, let's look at the tryhackme room ICE. So open up your web browser. You should be able to paste. And again, I think I'm still logged in. Excellent. All right, so it says this is a room. You'll probably have to join room. I think it'll say like join this room to continue. Go ahead and do that. The virtual machine ICE can be downloaded for offline use. So this is a really cool thing. I guess this guy hosts these images that you can download and import into VirtualBox, and you could have students or whoever run through them offline or at home without internet connection. So that's kind of fun. So you could replicate a lot of this without having to have access to internet even. So you could do this like an offline lab environment. Very cool. So what's it saying here? Go to our page. Oh, we got to connect to the VPN. If you haven't done that, they're kind of giving you a walkthrough right here. Go to the access page, download. I'm gonna go ahead and open that in a new tab. I know that it's in my downloads folder, and I can sudo open VPN, my username.ovpn, Kali password. And I know that as long as it says initialization sequence complete, and I have the little, once I refresh, I have the little green check mark, I should be good to go. So I'm going to minimize that terminal, open a new one to replace it. Zoom in a bit. All right, so we've done that. We've downloaded it. We've connected. So we can, do that. We've completed. Hey, we're already done with the first task. So let's go ahead and press on to recon. So this is using Nmap. So we learned a little bit about Nmap in some of the previous labs. So I'm going to go ahead and start the machine. Okay, and it's telling us either connect or use the attack box. Okay, where are we at? How are we getting there? So it says deploy the machine, may take up to 3 minutes to start. The next task or question says launch a scan against our target machine. So I recommend using a SYN scan to scan all the ports on the machine. The scan command will be provided as a hint. However, it's recommended to complete the Nmap room prior to this room. So without using the hint, let's try to tease apart what this thing says. It said use a SYN scan. I'm going to open up VS Code as well to sort of take notes, because it's a good idea to take notes as you go along. So I'm just going to start with a new file, empty, sort of blank slate, so that I have it ready to go when I want to take notes. Boom. All right, so a SYN scan. Nmap-H. Oops. If I scroll up, I can look at the scan techniques. So there's a TCP SYN scan, the connect scan, the ACK window, and then MIMON or whatever. So SYN scan -SS. So that's the first step to our command. So let's do this. Nmap tac SS. We know that we want to do a SYN scan. The next part of the question said we want to set to scan all the ports. So let's look at our help dialog. Let's look at the ports. How do we specify ports? Right here, port specification in scan order. So TAC P. Okay, so there was one thing that there was a shortcut, TAC P, to scan all the ports from 0 to 65535. Is that right? 65535. That would be 6,536. 65,536. Okay. Yeah, that's correct. So there's that. And then what else does it ask for? Scan will provide it as a hint. What are some things we might want to get from this send scan? In addition to this, we have a target. Something they told us to do is to sort of treat it as up regardless. I'm sorry, PN. Let's look. What does the PN do for us? Treat all hosts online, skip host discovery. Okay, so that's it. If it's not configured to respond to ping, Nmap would say, oh, okay, well, it's closed. There's that. You don't have to do this, but it's not a bad idea. And we have to have a, let's say, a target. So Nmap, send scan, all the ports. This, what other information might we want? It's like pretty common as you're doing like initial discovery. If you're going to hit all the ports, you might as well get all the information you can out of it. So you could give it a -SV, I'm sorry, lowercase SV for versions. Big A is one that I just go with if I'm trying to enumerate a machine. This is a test environment. We don't have to worry about being stealthy or anything like that. So I think this command would give us a bunch of interesting information. But one thing we didn't do is save any of those results. So another thing you might add is -O, A, O, A. And what is that going to do for us? That's output. I want all the file in 3 major formats at one time. Okay. So, and I'm going to call this ICE is the base name. We'll see what that yields here in a minute. And then I guess, all right, it looks like our machine is up, so I can replace where it says target. I can just replace that with the IP address. So let's zoom out a bit. So our command nmap, send scan, all the ports, TACPN for, don't try to ping it first. Do all of the common like OS version, so on and so forth on, and then save the results starting with ICE as the name. So you'll have ice.gnmap, ice.nmap, and ice.xml. And then this is the target machine. I say that's a fair start for an nmap. Copy. We go here, down. So do we think this will work as it is? I'm afraid that it won't because of this send scan. I think there's one additional thing we need to do, and that's make it pseudo, because we're abusing the protocol a bit, and we're sort of lying about what we're doing with the send. So we need to, that scan, the SS requires administrator privileges. Just remember that. I'm going to hit enter. My password is Callie. All right. So, oh, dang. I'm going to go ahead and kill it. I know this is a lab environment, so I'm going to be super aggressive with my timing. -big T5. We learned all of those things in that nmap room. -T5. Higher is faster. Oops. So, oh. All right, there we go. Sorry, filled up the screen a whole lot. There we go. So this is going to take about 5 minutes. So I'm going to pause and impatiently hit this video until it comes back. All right. And second thought, it's not fair to you to sort of let you out off easy. It takes time. So you can see I didn't wait very long. So we're just going to sit. We're going to watch this. That's the way it goes. We're at 38%. I guess, all right. So meanwhile, it says once the scan completes, we'll see an interesting number of 4. I guess we started the scan. So we can go ahead and compare notes maybe. What's there in map? Ah, yes. So they ran in map, SYN, TACP, TAC, target IP. All right. So we did a lot more. So we're gonna, ours is gonna take longer, but we're gonna get a lot more information as well. And we'll be able to reuse that information because we saved it. So yeah, there's that. Got that going for us. All right. As once the scan completes, we'll get a number of interesting ports. As you might have guessed, the firewall has been disabled. With the service completely shut down, leaving very little to protect this machine. One of the more interesting ports that is open is Microsoft Remote Desktop port. Which port is this open on? All right, so while the scan's coming back, I guess we can do some preliminary research. Microsoft Remote Desktop. Let's go ahead and right click Google port number 3389. When you connect to a computer, Windows client, server, remote desktop client, computer hears the connection request through the defined listening port 3389 by default. Okay. What port is this open on? It doesn't cost anything for us to add this, but we'll look. I think it's 3389. I'm going to guess because that's what the documentation says. That's from docs.microsoft.com. The scan, though, is the truth. That's like if they configured it to run on a different port, then obviously that answer would be incorrect. So and then I guess we can't even what does Nmap identify as the host name of this machine? All caps for the answer. So we can't even kind of answer these questions until we've gotten the results of our scan back. So this is saying, you know, roughly 20 seconds remaining for the SYN scan, but we also told it to do a version scan and operating system timing. So we're going to have to wait a little bit longer. That's with that big A, it's a big job. So on all the ports. Normally when you just run Nmap by default, runs like the top 1,000 ports. According to Fyodor. So nearly. We should have ran our TAC VV as well. That was what they told us in the Nmap room. Run TAC VV to get like a lot more input or output rather about what's going on during the scan, like why ports are closed, why ports are open. So I've just been kind of spamming the space bar and the inner key. So now we're doing the service scan timing. So this is different than the send scan. So now we're actually having to interact with all of those ports that it was determined were open. But this is already halfway done. So we just had to knock on every possible door, finding ones that open. That's why that took so long the first time. Okay. %. And I'm really glad that we chose to save our output on this, because if something happens to our computer, or if I clear the screen or something to get rid of all this extra text, that stuff might go away. Nice. All right. Let's see. What do we have? Oops. So this is the start of the output, right? So we've got these ports open, this port open, this port open, this port open, and these other high level port or high number ports open. Those are called like ephemeral ports sometimes. Because we did the -A, it's doing the operating system guesses as well. So it believes that it's Windows 7 or Windows Server 2008. In some instances, it might know for sure because the protocol tells it what version it is. So yeah, it's 97% sure that that's the version that is. Probably because SMB OS Discovery, one of the host scripts that it runs, tries to sort of figure out what, like, part of that protocol is like, hey, this is a version of the operating system I am. So version 7, Windows 7. We got the computer name. I saw that. What does Nmap identify as the host name? The host name is the computer name, kind of the same thing. I'm going to do dark-PC, copy, paste, submit. Oh, okay. What was this first port? Once the scan completed, yeah. One of the more interesting ports is open is Microsoft Remote Desktop. Where is Remote Desktop? I don't see the words Remote Desktop. So this is one of those things where you just kind of got to know to associate visually. Once you see 3389 in this MSWBT server, that is just sort of in your mind, understand that is RDP, Remote Desktop Protocol. I think that's the right answer. Whoop, whoop, our answer is correct. What service did Nmap identify running on port 8000? And it says first word of this server, IceCast streaming media server. IceCast. Submit. Whoop, whoop, our answer is correct. Is that what the hint says? If Nmap didn't show you the service name, then try running the scan again with the possibly with with version enumeration switch on. That's the SV we were talking about. We got that because we used tech big A, because we wanted operating system, versions, and some other stuff. What is the hint here? Nmap doesn't show you the host name. Try running the scan again with the common scripts. Now we got that information because we ran big A rather than just tech C. So you could be a little more surgical with Nmap if you wanted to, but we knew we were going to ask those things, or we were going to be asked those questions anyway, so we might as well have the answer to them. It's always good to have that information. So did we answer all the questions? Oh, yeah. Yeah, boom, on to the next one, gaining access. So IceCast, what is IceCast? Streaming media server, currently supports OGWARD, yada, icecast.org. If I go to their website, it can be used to create internet radio station or privately running jukebox and many things in between. Very versatile, new formats can be added relatively easily. Okay, so it's like a radio station. So what happens if I go here, and I want to go to that particular site. How do I do that? 8,000. I target port in a web browser. Because it's HTTP, that's why I'm using a web browser. Okay, and it tells me the source you requested could not be found. All right, so there's not much to see right there. Natively, what are they asking us to do? It says you identified some interesting services running on the machine. Let's do a bit of research into one of the weirder services identified. IceCast, or well, at least the version running on our target, is heavily flawed and has a high level vulnerability with score 7.5. What type of vulnerability is it? Use this website's for the question, for this question and the next. I don't know. Could we get version back information on that? I'm gonna go ahead and clear the screen, not to worry, because I can type code to open up ice.nmap. Let me look at things real quick. I have 3 files. I have ice.xml, ice.gnmap, and ice.nmap. Ice.nmap is text as it showed up on the screen. gnmap is all of that stuff kind of squished into one line. And XML is well, it's XML. So it's like HTML, but different. You can use it to import and export into other programs. So let's code ice nmap. And here it is. So we don't have a specific version. So how do we know? Like, it's saying that this is vulnerable. At least the version running on our target is heavily flawed. Maybe we need to run a more in-depth scan. Nmap -p, or I'm sorry, SV for version. Let's try it. -p, we only want to do one port, 8,000 at our target. So I'm going to go here, here. Yeah, we didn't get anything different this time around. Let's see, what is it doing? It says discovered open port. I ran it with the TAC T5 and a VV just to kind of see. Yeah, it still didn't really tell us any additional version information. How could we probe that? I'm gonna go back to the page. I'm just gonna kind of go around. View page source. Let's see, nothing really there. I don't know. All right, what does this thing say? If I go, let me go here. I'm just going to look. Ice. It says it's vulnerable, but how would I know that? It didn't say a version number. It didn't say anything. They're saying that this one had a CVE of 7.5. Number of vulns. Code execution in 2005, 2004, 2003. Structure traversal. Ice. Root code execution. Well, let's look at the hint. How did they? This type of vulnerability allows to execute arbitrary code in unauthenticated fashion. The name can be found in the vulnerability type on this website. When I go here, what they're looking for then, I guess, should be remote code execution. And then I'm looking, IceCast. Find it, vulnerabilities, I want to see them, okay. And it's hard to sort of see this page. I guess they're going back in time. Let's look at them from, they said, and so this is like metagaming a little bit here. It says we're looking multiple buffer overflows in the XSL parser for IceCast 220. This is a 7.5. And it's remote code. It says DDoS code overflow. So what is the answer they're looking for? 1, 2, 3, 4, 5, 6, 7. Remote. Well, that's not remote. Code execution. So what type of vulnerability is this? Looking, I'm gonna guess it's this one. Vulnerability type. Denial of service. Execute code overflow. I guess. So, like you're getting code execution by way of a buffer overflow, I'm guessing. Submit, yeah, okay, fair enough. All right, CVE number for this vulnerability. This will be in the format CVE, yada, yada. All right, so if that was the correct answer, then that means that this CVE is probably the right CVE. What do they say? Disclosed in 2004. Can be associated with a service found in the final task. This link has some additional details about the CVE. Exploring. All right, so it says disclosed in 2004. Publish date. Maybe this isn't it then. Let's try it. Vulnerable versions, products affected, version details, vulnerabilities. I'll say that's kind of a low number. Maybe it's possible that it I don't know. I don't know, submit it. That was not it. Okay. All right, that's not it. Let's go back. It said 2004. Here's another one then, right there. Also a 7.5. Let's click on that one. Okay, so this is a CVE copy. Let's paste, submit. Looks like we have the right one now. Okay, cool. So that information will come in handy. Now that we found our vulnerability, let's find our exploit. For this section, we'll use the metasploit module associated with this exploit. Let's go ahead and start metasploit and start using the command msf console. All right, so what do we do? I remember, I guess the first thing we do before we start up, we want to make sure the database is started. So we can sudo msf db. Now you can always type init, but I think start will sort of skip some other things. So I always just type init because it's not really going to hurt anything. Starting the database, and if it already is initialized, all you've done is start the database. So it's going to skip initialization. Great. Now we can type msf console. All right, and we're done. So we can just hit correct answer. So after Metasploit has started, let's search for our target exploit using search IceCast. What is the full path starting with the exploit? So before we do that, because we saved, like this is something, because we saved the results of our scan, we can pull in all of that information into Metasploit. And some of those commands we were talking about with like DB nmap and services and things of that nature, those right now we have a target machine. This is old information. This information is not accurate. This is from yesterday or whenever it was that you watched that particular video. So what can we do? Workspace tac H. So I can delete all of my work. I'm going to start fresh. This is a new operation, a new set of machines that we're attacking. So workspace dash big D to delete all of them. So it's recreating the default workspace. If I look now, I have no hosts. I have no services. There's nothing that exists. What I'm going to do is db_import, and I think it's called ice.xml. All right. And what that does is that brings in all of the results of our nmap scan into Metasploit again. So now if I type hosts, I should see our target right here. If I type services, I should see all of those things that were in nmap, except now they're in like a way that's a little more easy to, I guess, sort of tease apart. So do we have IceCast on here? Yeah, right here, IceCast. That's what we're looking at. So it's telling us we need to search IceCast. Okay. Search IceCast. All right, so I was super excited about this feature that I sort of learned how to use in helping you learn how to use it. So apparently it queues up the last result, so I can type just use and then the result number right here in order to type that one, rather than typing exploit Windows HTTP. Rather than having to type all that out, I can type use 0. All right. And it said no payload configured, defaulting to Windows interpreter reverse TCP. Okay. So what's the path here? What's it say? I think this is what they're looking for. The path to the exploit module. Paste, submit. I think that was correct. Excellent. All right, let's go ahead and select this module for use. You can use IceCast or use 0 to select our result. Complete. Man, I must have been like seriously sleeping on that as a thing. I never noticed that you could do that. Excellent. Okay. Follow selecting our module. We now have to check what options we have. Oh, show options. As usual, every time we use a module, we want to show the options. Show options. Okay, so the rule of thumb I have is I check to see what is required in this required column and what has a value. More often than not, like our port will have a value. Pretty much if it doesn't have a value there, you need to plug it in. So show options. What is the only required setting which is currently blank? And that's going to be our hosts. So we need to set it. It says first let's check the lhost option and set it to our ton0 IP, which can be found on our access page. All right, so I'm going to open up a new terminal. Zoom in, IP adder. This is my IP address right here. Why can I not click? What happened? Ah. Okay, well, I don't know why it won't let me click that, but at any rate, it says first let's check that the lhost option. So right here, it says the listening address, like that is set, and it's required, but it's not correct. So let's set lhost. If you hit the tab key, it'll give you a list of options that you can select from that are, or not select, but, you know, sort of prompt and see which ones are correct. 2.4.29. And tab again is your friend. So this is the network, the IP address that is on the VPN network. It's adjacent to our target machine. So that's the L host. That's where it's going to receive a connection from. It's going to be listening for connections at that IP address on port 4444 right here. So when you set something, not a bad idea to show options again to verify the settings took. We still need to establish a target, set our host. And again, if I tab it out, it should let me prompt for, again, this is my IP address. This is my target IP address. Just be mindful of that. Okay, we've done this. So set the L host. Let's run our exploit using the command exploit. Exploit. I think, well, hold on, what did I say? I said show options, verify that everything's set correctly. This is wrapped around. That's why you see it right there. There we go. Our host, port, other information. Zoom back in. Now we are ready to exploit. Let's see what happens. Okay, excellent. It says we started our reverse handler. That's our listening post. That's where we're going to be receiving information. And then we see this next message, sending stage. So my interpreter sent across a staged exploit. So it sent a little bit of exploit code, and then it did the exploit. And then it said, hey, reach back to my IP address on port 4444. That's the 4.29:4444 that you see. And request the true, the real, the big payload, which is Meterpreter. Meterpreter gets downloaded, and then it says, oh, Meterpreter session 1 opened here to there, and it drops you into the Meterpreter shell. We spent a little bit of time messing with the Meterpreter shell in one of the other videos. So now we're in escalate. All right, so remember, exploit, escalate, persist, right? So woohoo, we've gotten a foothold onto our victim machine. What is the name of the shell we now have? I think this is going to be Meterpreter because I'm sitting on a Meterpreter shell. It'll be the name displayed in the command prompt. Meterpreter. Copy selection. Submit. Whoop whoop, our answer is correct. Nice. What user was running that IceCast process? The commands used in this are taken directly from RP Metasploit room. So if we don't know what we can type right now, we can type help. So what can I do? Let's see. I'm looking at this. What user was running the IceCast process? I think PS will be of some help. Let's see, what else? UID, use exit info. No. Let's see which one. I'm gonna guess PS and see if we can't find that information. What user was running the IceCast process? Taken from this room. So I looked at IceCast right here. And again, if we zoom out, we're getting some sort of garbled output. Like normally it shows up in one line. And we can see that this is the IceCast process. If I look at get PID, that's get the current process ID, 1976. I can see that 1976 is the process in which I am running. I've taken over the icecast2.exe process, and I've told it to sort of do my code instead of the icecast code in this instance. So it's asked in part of this PS command will show the user that if it's available to them, the user that's running that process. So it says what user is running that icecast process. Capital D dark. I am curious, what was their solution? Get UID. Oh, I see. I totally misread the question. So, yeah, all right. So get user ID. I got the process ID, and I can also get the user ID, which is effectively just this column for this particular current process ID. All right, anyway, more than one way to raise a cat. What build of Windows is this system? So we can type sysinfo. Again, how do I know that? I type help. And I'm gonna scroll up. Where was it? Sysinfo. Get information about the remote system, such as OS. All right, sysinfo. And it looks like what build of Windows is this system? It looks like 7601. 7601. Very common Windows build. Sysinfo, it tells you the commands in the hint. So that's cool. So we'll try that process the whole way down. We'll like guess the command and then we'll verify it with the hint. Now that we know some finer details of the system we're working with, let's start escalating our privileges. What is the architecture of the process we're running? I'm gonna guess because this is the 32-bit version of Meterpreter, it's probably a 32-bit version of Icecast. So PS, again, looking at this, Icecast 2, and this is, again, not necessarily the law, but convention, because it's in the C program files x86, that's generally 32-bit versions of executables, like 32-bit installations. First, what is the architecture of the process we're running? So I'm going to say x86. x64 is generally 64-bit. How do I get that information with sysinfo? I guessed it. Again, it actually, I didn't guess it. Yeah, I guess it did. x86, it tells you the architecture right here in the arc column. Sysinfo. Architecture. What is the architecture of the process we're running? Ah, interesting, interesting. This is a 32-bit operating system. Oh, no, it's not interesting. It's exactly what I just said. So 32-bit installs, and then if you're on like a 64-bit, I'm sorry, if you're in a 64-bit version of a program, it's not going to be in program files x86. It's just going to be in program files / Firefox or Icecast 2, so on and so forth. This also has the added hint Win32. So Meterpreter's 32-bit. I'm going to guess that that's what that is. Submit. Nope. It says, what architecture of the process we're running? Well, I guess the only other answer is 64. We got it. We got that correct there. I'm not convinced that that's accurate. I must voice my concern on that. But now that we know the architecture of the process, let's perform some further recon. While this doesn't work best on x64 machines, let's now run the following command. Run post multi-recon local exploit suggester. Okay. This can appear to hang as it tests exploits and might take several minutes to complete. So I'm going to copy this. I'm going to paste it. And let's see. So how do we know, what is this going to do? This is going to try a bunch of, it's like a shotgun approach. It's going to try a bunch of different things to figure out how do we go from being just a regular user to an administrator user? How do we escalate our privileges? So, and it's going to try to find a bunch of different vulnerabilities to do that. So I'm going to hit enter on that. and it's going to go and download that tool that it's going to try to run and all of those steps, because they don't live in Meterpreter themselves. They live on my attacker machine, and then it's going to run through that process. So this, it said it may take a while, so let's kind of just sit back and watch it. All right, so it says it's checking all of these exploits. Okay, so what's the first one? It says running the local exploit suggester will return quite a few results for potential escalation exploits. What is the full path starting with exploit for the first returned exploit? I noticed the color change here. Target appears to be vulnerable to this particular exploit. So I'm going to copy that. I'm going to exclude the colon because the colon seems to be not part of the name per se. So I'm going to hit completed on the top one and then paste that. So what did they come up with? The answer will include event viewer, and it does include event viewer. Hit submit. I think that's the correct answer. Now that we have an exploit in mind for elevating our privileges, let's background the current session using the command background or Control-Z and take note of which session number we have. This will likely be 1. Using the sessions command, yada, yada. Okay, so what are we saying here? Saying background or get out of this shell, get back to MSF console. That's going to be a core command. How do I get back to my computer? Because right now I'm on their computer. How do I get back to my computer? I can background the current session. So you can type background, tab completed, or simply BG. Backgrounding session 1. So session 1 is important. That's what they were saying. Take note of that session ID. If you don't know which session you had, you can type sessions, plural, and that'll list the sessions that are available to you. So you have a Meterpreter session, 32-bit version, Windows Meterpreter, on this machine running as the dark user. That'll be important here in a little bit. At this particular port and IP and all. So this one is saying, get out of the shell. So go ahead and select our previously found local exploit by using the command use full path for exploit, which we found right here. So I can type use that. Okay. So anytime we use something, we want to show the options. It says module options. Everything that's required will have required in the required column, or yes in the required column. And this is the only thing that has a no value currently. And it's asking for a session. This is that session ID that they are asking for. So if I set a variable, I use the set session 1. And again, that information is found when I type sessions. I listed all of the sessions that are there. Session 1, show options. And this time around, I noticed that this IP address, not correct. This IP address is not the IP address that my target machine knows how to communicate with. So I need to update lhost, set lhost to my IP address. How do I find my IP address? If I type IP, I can do this in another terminal. Say that. I can type the IP address command. Ton0 is my tunnel to tryhackme's network. So that's 10.2429. So I can copy that, close that terminal. Set lhost All right, show options. Okay. So now that we've set our session number, further options will be revealed in the options menu. We have to set one more as our listener IP isn't correct. What's the name of this option? Okay, so that's lhost. That's their listener IP. Submit. Whoop, whoop, that was right. Let's go ahead and click those to get done with them. It says set this option now. You might have to check your IP on tryhackme network using the IP adder command. We did that already. After we've set this option, we can now run our privilege escalation. Run this now using the run command. It might take a few attempts. You may need to relaunch the box and exploit the service in the case that this fails. This is something that happens. We call it like knocking over a box. So you'll crash the machine. You're telling the machine to do something that is technically possible, but you're tricking it. You're telling it to do something that is not initially designed or intended to do by way of like running your shell code. So there might be some process in there that locks up the computer and forces it to restart. So you'll have to, if you do that, that's why it's important to get persistence on and maintain access on a machine as quickly as possible, because you never know when that machine might go offline and maybe no longer be in a vulnerable or exploitable state for some reason. So that you don't want to make, or if you do, you're going to lose a lot of work trying to get back to the exploited state if it is continuing to exist in an exploitable state. So let's go ahead and run this and see what happens. So it starts our reverse handler, UAC enable, checking level, continuing. It's telling us everything it's doing right there. Event viewer is successfully connected. Wait for payload to execute. Interpreter session 2 opened. Cleaning up, showing registry keys. All right. Sysinfo. Get UID. Looks like server username is dark, but I don't know that it actually. Oh, let me run get privs. I should have done that before. Get privs. Oh, wow. So now I have all of, and so this didn't make any sense to show because we hadn't. Oh yeah, we can. Hold on. I go BG, backgrounding session 2. Sessions. I'm going to look at, I'm going to interact with session 1. Sessions, tac I1, get privs. I have 5 like Win32 API, privileges, and they are, okay, I guess I can shut down, I can modify the time zone, or I can undock the computer or something like that. In session 2, I told it to invoke with a different set of privileges. SE debug privilege is very important. That is this line right here. SE impersonate privilege. Why? This means I can read, SE debug means I can read other processes' memory, and SE impersonate privilege means I can assume the role of that user, of another user. I can present a token as another user. So those two are important. I'm going to get out of session 1 because that's the method of communication I have, which is not privileged at this point. It's not super advanced. So I'm going to hit Control, BG, just the background. You can hit Control Z, I think will also do it. And I want to interact with session 2, session-I number 2. Now I'm interacting with session 2. Same computer, different means of communication with it. And I guess we can jump back and forth when we look at Mimikatz and such. What permission listed allows us to take ownership of files? I guess take ownership privilege, SE take ownership privilege. Copy selection, paste. What did they give us? This will be close to the bottom of those listed. That's close to the bottom. Submit. Boop, that was correct. Next. Looting. All right, so this is where we, get Fun stuff. Ah, Mimikatz, great. All right, so prior to further action, we need to move to a process that actually has permissions we need to interact with the LSAS service. Notice the LSAS service is, I'm sorry, this service is responsible for authentication within Windows. First, let's list the process using the command PS. Note that we can see the process is run by NT authority system as we have escalated privileges, even though our process doesn't. Nice. Okay, so if I run PS, before all we could see were our own processes. Now, because we have SE debug, impersonate, yada, yada, we can now see these NT authority system and likely migrate to them because of the SE debug privilege. So note we can see a process running by, it has escalated privilege, yada, yada. I'm gonna hit next. In order to interact with LSAS, we need to be living in a process that is in the same architecture as the LSAS service. So we're in a 32-bit process right now, IceCast 2. That's why that question earlier I think was wrong. But we're in a 32-bit process. We need to migrate to a 64-bit process that we control, like I'm going to say explore, for instance. I don't know that that's the one we'll use, so that it can migrate to a 64-bit. All right, so let's see. The printer spool service happens to meet our needs perfectly, as if for this, is it'll restart if we crash it. What's the name of the print service? How do I find that out if I don't know what it is? Windows print service. Specifically, Windows 7 print service. Name. I'm going to do that. Scrolling. Do I find anything that shows me on the front page? I think how to stop and start. What are these videos telling me? Enabling the print. Dang it. Okay, well. What's this first one say? I don't know. I'm pretty confident this is the answer, but like, how would I have known that without, if I didn't know what it was, right? Services, MSC, change, how to stop the print spool service. That's not it. Well, you could Google them. You could, I mean, like, this is just one thing to know. The print spool service just works sometimes. Just remember that, okay? I'm pretty confident that's going to be the answer. This printers will spool documents. Ah, yes, they certainly will. So spool service.exe, submit. Nice. All right, migrate to this process using migrate tac in process name. I don't like to do that. I don't want to use migrate tac in process name. I want to use migrate process ID. And I hope that it works, otherwise I'll look dumb. 1392, because that's more explicit. If for some reason there is another spool sv.exe running on this machine, maybe it's not a legitimate spool service. Maybe it's another program that is about like spooling bobbins of thread for an embroidery machine. I have no idea. Just saying, maybe you can be more specific by saying the migrate process ID. And so it's migrating from 2540 to 1392. 2540 is PowerShell.exe. Well, how did that come to be? Well, that's the Meterpreter shell that I'm living in, or I was living in, that was spawned by exploiting with escalated privileges by exploiting our ability to remotely execute code in the IceCast server to establish a Windows event viewer bypass UAC, like local privilege escalation exploit, to run a command of our choosing at some point in time, I think. And that was the PowerShell.exe, which called back to us with escalated privileges. Now we've migrated away from that process, this 2540, into some new process, in this instance, the print spooling service. Cool beans. What happens if I run PS now? It looks like my 2550 or 2450 went away, no longer existing because I mean, no reason for it to. That process is dead, it's done. And we now live inside of the print spooler. So I've done this. Let's check what user we're running with the get UID. Get UID. INT authority system. It doesn't get any higher than this. This on Windows, that is, if you're an administrator, you're still not the highest level of privilege. INT authority system is the highest level of privilege in the Windows, I don't know, like from our perspective, I guess. Submit, let's see if that's correct. Whoop, whoop, we are correct. Now that we've made our mate, let's run the get privs again to see. Get privs. We have what looks like fewer privileges, but I think ultimately it's not gonna bother us. So let's see. Load Kiwi is what we need to run. Load and Mimikatz. Let's do that. Mimikatz. Beginner's Guide. This is from not too long ago, from 2020. It's an open source project, so let's go here and look at the code on GitHub. Mimikatz. As of the time of recording, it was updated within a week, 2 weeks, last 3 weeks. It's been, someone's been actively working on it, making it better, adding new exploits, or not necessarily exploits, but maybe changing like some feature set. So it's an active project. And I guess today's date is May 25th, 2021. So within the month of May 2021, there have been updates to this code base. So the way that we access it is load Kiwi. It's going to reach back to our machine, download this module, and then inject it into the process memory over there. So what happens when I type help now? I have a new menu. I have Kiwi commands. Before, I had standard API. I had privilege, elevate commands. This one kind of comes with you. It's free. It'll probably throw up some red flags if you run it, but it sometimes works. So what am I trying to do here? Retrieve all credentials, retrieve certain kinds of credentials, particularly the NTLM credentials are useful. Let's see, what are we going after here? I've kind of lost track, start wandering. Now that we've made our way to full administrator permissions, we'll set our sites on looting. Mimikatz is rather infamous password dumping, yada, yada, update it, okay, completed. Loading Kiwi into our interpreter session will expand our help menu. Let's look at that. Completed. Which command allows us to retrieve all credentials? Creds _ all. Copy selection. Let's paste it. Be mindful of the spaces at the end. I'm gonna see if the spaces at the end, if they like trim off the white space for you. Yeah, they do. All right, good deal. All right, so run this command now. What is Dark's password? Mimikatz allows us to steal this password out of memory, even without the user Dark logged in, as there is scheduled tasks that runs the IceCast user as the user Dark. Runs IceCast as the user Dark. It also helps that Windows Defender isn't running on the box. Yeah, so this box doesn't have Windows Defender, so no, the built-in antivirus. It does not have a firewall enabled. So that's what I guess the point they're making it at the end. So I'm gonna paste that again, creds all. Sweet. All right, so it pulled these things out of memory. I'm going to copy that, paste that, submit. All right, so we've escalated our privileges. What are some other things we can do? Before we start our post-exploitation, let's revisit the help menu one last time. In the interpreter shell, we'll answer the following questions using that menu. Completed. What command allows us to dump all of the passwords hashes stored on the system? We won't crack the administrative password in this case, as it's pretty strong. This is intentional to avoid password spraying attempts. Password spraying is where you have a known password. It's not a brute force attempt exactly. It's weird. Why would they say password spraying or like brute forcing? You try one password across a whole domain. So I know this password, and maybe Dark is also the administrator on this computer. So I try this password for all of the user accounts in an organization. So that's password spraying. What command allows us to dump the password hashes? I think that's hash dump. If I look up, or maybe this one, DC sync. I think hash dump. I'm just going to type it. Hash dump. Yeah, that was correct. Okay. Again, as soon as you get elevated privileges, not a bad idea to go ahead and get that. Credential access is that's the best thing. Like, it's better than the exploit because you can just walk in the front door, kind of. So. All right, so while more useful when interacting with machine being used, what command allows us to watch the remote user's desktop in real time? Something with, let's watch, let's look. Range of interpreters, current desktop, screen share. Interesting. So if I've gotten someone to plug in a flash drive and open up a malicious document, this, that has an interpreter shell that phones home to me, my listening post, I can, what am I saying here? I can turn on the screen share and then watch them initiate a bank transfer, sort of watch what that process looks like, right? I learn how to use their applications kind of surreptitiously in the background. So if I'm trying to act like them in the future. So how about if we wanted to record from a microphone attached to the system, scrolling through this, record_mic. Record_mic. That was right there. To complicate forensic efforts, we can modify timestamps of files on the system. What command allows us to do this? Don't ever do this on a pen test unless you're explicitly allowed to do so. This is not beneficial to the defending team as they try to break down events of the pen test after the fact. So I guess the point that they're talking about here is that this is like, I don't know, I think time stomping is that term in general, like you're, rather than a timestamp, you're stomping on the clock, you're breaking it. This modifies read and write access times, the MACE, the modified access changed, and I don't know what E stands for, but it's something, an NTF file system like timestamps. MACE means something. I guess I can Google it real quick. Right click, copy, timestamp MACE. What's that do for me? MACB, modified access changed born. Birth. entry modified, modified access created this. Okay, cool. So that's what that means. Timestamp. All right, Mimikatz allows us to create what's called a golden ticket. Oh man, allowing us to authenticate anywhere with ease. What command allows us to do this? Golden ticket attacks are a function within Mimikatz which abuse Kerberos, the authentication system in Windows domains, the ticket granting ticket. So Kerberos ticket granting ticket. That's what we're doing here. Okay, in short, golden ticket attacks allow us to maintain persistence and authenticate as any user on the domain. So if I look at my Kiwi commands, what does it say? Create Kerberos golden ticket create. Boop, that answer was correct. Nice. All right, one last thing to do is as we have the password for dark, we can now authenticate to the machine and access it via remote desktop. As this is a workstation, we'd likely kick whatever user is signed onto it off if we connect to RDP. However, it's always interesting to remote into machines to view them as their users do. If this hasn't already been enabled, we can enable it with the following metasploit module, enable RDP. So this is going to turn on the RDP service on this remote computer. So let's do that. Says RDP is already enabled. So one nice thing they've given us here is that it gives us this cleanup script. So what this is going to do is because again, we're supposed to be the good guys in this. Like we're supposed to be helping people. We're not creating holes and like busy work for the blue team to go and clean up after us. So this right here is a script that we can run, which will kind of like undo that. So let's see what's in it. I'm going to type copy selection. PG, because again, I was not in my computer, I was on their computer, and they don't have Visual Studio Code installed. It's not an interpreter command. With any luck, that'll open up. Okay. So you can run this as a bash script, or at the very least, you can just sort of use this as a starting point to sort of build a remedy to some of the actions you've taken. So I'm gonna, what are they saying we can do? We can RDP into it. Let's do that. I'm gonna click on my application menu. And then type RDP. And then I think, is XRDP, why is my clicker not clicking? So I think there's a, well, what's another way we can search for software? Let's see. Applications, system. Okay, well, what I was going to look for was like an RDP terminal viewer. Let's see, open up a new tab here, or a new shell. Sudo apt install Kali RDP client. Our desktop. That should already be there. I would have bet money that it was there. Our desktop. Our desktop exists. Okay. So remote desktop client. So our desktop, and then it looks like I have to just type server : port. And the server is 10.10.115.177:3389. 3389 is just the default port. Do I trust that certificate? Why, yes, I do. Yes. Nice. Okay, so it's giving me like a Windows login thing, and I can't click, unfortunately, because my mouse is broken. I log in as other user, and the username was dark, and the password was PASSW0, no, ORD01 exclamation. It surely was. Nice. All right, so now we're like able to go through and like visually sit as if we were like on their computer and like rifle through their files and steal their documents and their music and such. Start later. Close that. My mouse is broken for this whole thing. I don't understand what that is. All right, extra credit. That's it, man. I think we've finished this whole room. Nice. In advance of your pen testing, exploit code, exploit DB, exploit link. If I follow that, oh, man, that's terrible. Why did they do that? So I'm going to open that link in a new tab. And so this is the actual code, or this is some actual code to exploit this IceCast vulnerability. This is actual shell code. Shell code is just a series of instructions configured in a certain way that the processor is going to, well, not the processor, but the Windows calling, like function calling convention, will know how to interpret these codes as legitimate, like assembly instructions once you've leveraged your buffer overflow. So I'm looking at all this. And this is just stuff to start the communication process and actually exploit. It's pretty cool. So nice. Exploit DB, again, is a place where you can go and research, exploits. I can come over here and type IceCast. We could have done this from the jump and found, maybe something really quickly, because you can sort by date. You can find the newest stuff on top, oldest stuff on top, whatever you're looking for, if you know when this machine was built out. So all right. Well, let's go back over here. It says completed. That's the end of the room. All right. Cool deal. And I think that is the end of that machine. Like, that's the end of it. We're done. We've hacked our way into it. We got it. We started with no connectivity. We were just on the network. We scanned the network. We found a vulnerability. We identified a potential exploit for it. We tried a couple things. Some of them worked, some of them didn't. We ultimately ended up escalating our privileges, turning on some services like RDP, maintaining some kind of persistence. Well, we didn't really do a whole lot of persistence, but and we ended up getting our goal of getting administrator access on that machine. So we're done with that room. All right. Well, that being said, explore some other rooms. So there's a sequel to this room. I think they called it Blaster. So I'll put that in the notes for you. So, all right, good deal. Thanks.